Welcome back, Pre-Algebra. We're in lesson 27 today. So lesson 27, and today we are going to talk about the area of a triangle. So there is a specific method for finding the area of a triangle. But first, let's talk about the area of a rectangle. So if I have a rectangle here, we know how to find the area of a rectangle. Let's say this area of the rectangle is, let's say this is 4, and let's say that this is 8. We know that we would take these two dimensions, let's say they're in meters, right? This is 4 meters, and this is 8 meters. And we would just take the area of this rectangle and say 4 meters times 8 meters, and that would equal 32 meters square. That would be the correct area of that rectangle. Now, in order to find the area of a triangle, we need two dimensions also. But a triangle is not going to be easily calculated in relationship to the rectangle because it only has 3 sides. So we have to use our imagination a little bit. So if I were to take a line and I were to draw it from diagonal to diagonal, I could argue that I have just created a triangle. This part is a triangle. And I could also argue, because this is a rectangle, and because we know that this side is parallel to this side, and this side is parallel to this side, that these two triangles are the exact area. They're identical in area. They're just flipped around from each other, right? We know that this length and this length are the same. This one would be 4 meters, and this one would be 8 meters. But there's absolutely no way that this triangle can be 32 meters and this one can be 32 meters because the whole rectangle is 32 meters. By using logic, I can visually see that this line that created these two triangles cut this rectangle exactly in half. So I can deduce from that what I need to do to find the area of a triangle is find the area of the rectangle and divide it in half. So what that means is this triangle here is going to be half of the total rectangle. So 32 divided by 2 is 16 meters squared. So what that means is this triangle is 16 meters squared and this triangle is 16 meters squared. Because when you add the two together, we get 32 meters squared, which is the whole value of the rectangle. So that leads me to the formula for the area of a triangle, which I usually write like that. The area of a triangle is the base, which is just the bottom dimension, whatever that bottom dimension is, times the height. And we'll talk about how to find the height in just a minute, divided by 2. And that accounts for using the value of a rectangle divided by 2 to find the area of the triangle. It's literally doing this right here. So let's try looking at some triangles and seeing what our different options are. Let's see how we can find the base and the height on a right triangle. So here's a right triangle. And a right triangle is one that has this 90-degree angle right here. Well, it's obvious this is the base, right? That's pretty standard and straightforward. It's the one on the bottom. And this has got to be the height because that is the tallest part of the triangle. So easy peasy on that one. We just take this number times this number and divide it by 2. Not a big deal. That's all we would have to do there, right? What if we have a triangle that doesn't have a 90-degree angle? What if we have, say, an isosceles triangle? And that would be where this side is congruent to this side. Well, if we have an isosceles triangle, we already have the base, right? But we don't know how to find the height. We have to be told what that height is, or be given some information that would allow us to find that height. The height is going to be part of the triangle to the base, and it's going to be a perpendicular line, meaning that you've got a 90-degree angle here. Just like you have that 90-degree angle here that takes you to the tallest part of this triangle, it's going to be the same thing here. You've got to have a perpendicular line that takes you from the base to the tallest part of the triangle, and that is going to be your height. The formula is still the same. I wrote it backwards, but it's still base times height divided by 2. Even if it's a different shaped triangle, that doesn't change it. What if we have an obtuse triangle? Like something like this, where the tallest part of the triangle is not inside the triangle. How do we measure that? Well, there's two things you can do with one like this, right? The first thing is you can find the height of the triangle here on the outside of the triangle. That's still a valid height. And then you use this base, this length right here. Or you can take this triangle and you can flip it around to where it looks like that, and then you could find the height here and use this base. It really doesn't matter which way you do it. It's still going to be base times height divided by 2, and it will give you the same answer regardless of whether you do the height this way or the height this way. So it just depends on how that triangle is presented to you and what it tells you the height is. That's all you're going to do. So let's try a couple. So here we have 27.1. I should have left those triangles up there because that's what we're doing. So here's a right triangle. Okay, that right triangle, this is 4 and this is 6, and we are doing inches. All right, so we have the base is 6, so 6 inches times 4 is divided by 2. 6 times 4 is 24 inches divided by 2. That equals, or that's 12 inches square there. 12 inches square. 24 inches square divided by 2 is 12 inches square. And it's inches square because we have inches once, inches twice. Okay? So now let's try that isosceles triangle, the one where it was over the center here. All right, so this one tells me that the height of the triangle here is 4 and the base is again 6 and it's in inches. Well, guess what? Same dimensions. The base is 6 inches times the height of 4 inches divided by 2, 24 inches square divided by 2, 12 inches square. What if we have that obtuse triangle set on its side like that? Well, guess what? This one has a height of 4 inches. And the base over here is still 6. Same value. We have a 6-inch base times a 4-inch height divided by 2. 24 inches squared divided by 2 is still equal to 12 inches squared. So it doesn't matter what the shape of the triangle is. What matters is, can you find the base and can you find the height? And if you have those two dimensions, then you can move forward and solve for the triangle. All right, and guess what? That's all we have for lesson 27. Just the area of the triangle. So be sure to write this formula in the back of your notebook. The area of a triangle is equal to base times height divided by 2, and that's what you need to remember. Okie dokie. All right, we are going to move on, and I will see you in lesson 28.